Hi, this is Charles Maggio. Welcome back to R for Epidemiology. In this screencast, I want to talk about cross-tabulations. We've already spoken about stratified analysis, marginal analysis, and probably the third most important initial descriptive kind of work that epidemiologists will do is cross-tabulations. In a program like SAS, and a lot of folks do work in SAS, this would be analogous to working with PROC FREQ, for example. The R function to do tabulations and cross-tabulations is the table function over here. And to demonstrate the use of the table function, we're going to recreate our data frame that we used to aggregate body mass index in a previous screencast. Just going to run through this code right here and show you what the data look like. So we have a data frame of age, weight, height, gender, the clinic that someone attended, and ethnicity. If I just want a count by one categorical variable, I just submit that categorical variable to the table and I get the count. If I want a cross classification, I just submit the second. And again, the first or the dimension on the left side of the comma will be rows. The dimension on the right side of the comma will be columns. And here we have age, we have gender by ethnicity. If I want yet a third dimension, which is analogous to when we're doing arrays, you will get something like this. At this point, this can get a little complicated to understand, but basically these are the three clinics. These are the cross classifications by clinic. This might work for you. It might not work for you. If you want something a little simplified, there is a variation or a form of table called F table, and the F stands for flattening, and it flattens the table. I'll submit the same three categorical variables. Instead of just using table, I will use F table, and what I get is something that might be a little bit easier to look at. Now, up until now, all we've had is counts. If you want the proportion within those cells, there is a function that works with table called prop table. Now, notice what I'm doing here. I'm using the prop table function, and prop stands for proportion. And I'm submitting as an argument to prop table a table. And this, you see, it's worth noting that this happens frequently enough in R that it's worth paying attention to. Sometimes you will only get the results that you want by submitting a function to another function, by submitting a function as an argument to a function. You'll see this in graphical summaries as well. So if you want a graph of a histogram, for example, you would summarize what you want the graph of, and R would return a histogram of some kind. But in this case, prop table takes as a function a table. And we've created three tables as we went along here. So table 1, table 2, table 3, table 4. And let's take a look at what they would look like if we just submitted them to prop table to get the proportions. And much as you would expect, so here is table 1, right? And here is the prop table for table 1. So these are the numbers, these are the proportions. For table 2, we cross-classified by ethnicity, and here's the proportions of that as well. And table 3, same thing. Now, what I want to demonstrate, what I want to point out here up until now, and you may have noticed it, but I'm going kind of fast, so I want to just point it out, is that, and this is the prop table for table 2, the proportion is the proportion of the total count. So these four proportions added together sum up to 100%, or a proportion of 1. If you want to specify one dimension or the other, if you want the row proportion or the column proportion, you do that with the option margin. So margin equal 1 specifies the row proportions, and let's submit the same command and specify margin 1. So now you see that the margins add up to 1 for each category. If I want to have the column proportions, I specify margin equals 2. Some folks really don't like the way R does this proportion, and a lot of students I've worked with and folks I've worked with that have come from SAS really like the way SAS does PROC FREQ. And SAS actually does a pretty decent job. Someone liked it well enough to create a workaround within R. So, if you are interested in receiving your results the same way you would for PROC FREQ, there's a way to do it in R, actually relatively straightforward. Download and install the gmodels package. And I already have it installed. And you bring it, so basically load the gmodels package using the library command. And now you have available to you a function called CrossTable. And let's run the same function. Let's run the same arguments for CrossTable and see what we get. And here you get that sort of like SAS formatted kind of outcome, which you may want, which you may not want. I actually find the SAS output, especially for tables, to be somewhat verbose. And even when I worked in SAS, and I used to work exclusively in SAS, I used to always put in options to make it less verbose and to cut back on the options. And anyway, that's cross-tabulations. It's very useful, very important. And at this point, you have a way to do marginal analysis using apply. You have a way to do stratified analysis using either by, tapply, or aggregate. And now you know that you could use the table function or crosstabs if you like to do or cross table if you like to do cross tabulations.